the future becomes the present. Monsanto Chemical Company, Plastics Division, presents the Monsanto House of the Future.
It's the 1950s, and plastics are just becoming popular. From plastic dishes to plastic bags, plastics became ubiquitous extremely quickly. But as we all know, plastics had unforeseen consequences. They were used all over the place, and people had no regard for the potential negative impacts they brought. Plastics are used for tons of one-use products, many of which end up in the water stream. Far too many plastics end up here. What you're looking at has been dubbed the Great Garbage Patch, the largest of many garbage patches in our ocean, located in the North Pacific Gyre between Hawaii and California. It is estimated that 99.9% of the trash in this patch is plastic. 94% of the total number of pieces of plastic in this patch are considered microplastics. Microplastics are tiny plastic pieces less than 5 millimeters in length, and they're showing up absolutely everywhere. You may have heard in recent news about bans on plastic bags and plastic straws. After all, plastics, especially plastic bags, kill an estimated 100,000 marine mammals every year. But there's a much bigger problem. Plastics in our oceans degenerate into microplastics, which are eaten by sea life and work their way up the food chain. One study found that an astonishing 73% of fish caught at mid-ocean depths in the Northwest Atlantic had microplastics in their stomachs. It is projected that plastic waste from coastal countries will grow almost 20-fold by the year 2025, and it is estimated that an average person ingests 5,800 particles of synthetic debris, including microplastics, every year. This is extremely concerning because the effects that microplastics have on humans are largely unknown, so more research is desperately needed. Researchers suspect that microplastic polymers contain chemical additives which are harmful to marine biota, putting the marine ecosystems, biodiversity, and food availability at risk. But there's another problem. Climate change is upon us, and we're already noticing its effects. From more intense storms to rising sea levels and temperatures, and melting sea ice, most are familiar with the adverse effects that climate change is having on our planet. Now, climate change is leading more plastics to enter the water stream, and making it harder to study and predict the movement of microplastics in our oceans. This is to say that climate change is making the microplastics problem even worse. A lot of plastic is trapped in Arctic sea ice, which is a problem of its own. Now with climate change, this ice is melting, and microplastics trapped inside are entering the water stream at an increasing and alarming rate. One study that examined the ice for plastic found what they described as a substantial abundance of microplastics, ranging from 38 to 234 particles per cubic meter of ice. The paper calls for action, stating that the potential for substantial quantities of legacy microplastic contamination to be released to the ocean as the ice melts, therefore needs to be evaluated, as do the physical and toxicological effects of plastics on marine life. Thanks to melting Arctic sea ice caused by rising global temperatures that have been attributed to climate change, microplastics are becoming more of a problem, and not a problem that anyone knows how to solve yet. Scientists are trying to study microplastics in our oceans to better understand their effects and find ways to reduce or remove them. But there's a problem, and once again climate change is at fault. The movement of microplastics in our oceans are influenced heavily by marine circulation and weather conditions. Climate change and its influence on ocean circulations is impacting the distribution of microplastics in our oceans. The melting of ice is expected to have a range of unpredictable effects on the spreading of plastics in our oceans. Let's break this down. As swimmers probably know, it's easier to float in salt water than in swimming pools. This is because when salt dissolves into water, it adds to the mass of the water, making it denser. Quite simply, it's easier to float in denser water. The density of seawater affects how debris will move and whether it'll sink or float. The density of seawater at sites with freshwater input is estimated to decrease the relative buoyancy of plastic debris in our oceans, which speeds up the rate at which plastics sink. When sea ice forms, most of the salt is pushed into the ocean water below, resulting in mostly salt-free ice. As such, Arctic sea ice melting releases more fresh water into the ocean and impacts the buoyancy of water. Also thanks to climate change, a rise in global temperature results in increased water temperature. This creates areas of high evaporation, resulting in plastics continuing to remain in the water column and surface waters. This heat also increases the rate at which plastic debris breaks down into microplastics. These changes in temperature also impact the scale and patterns of precipitation, cyclones, tropical storms, and tornadoes. Severe storms, floods, and increasing sea levels cause more coastline litter to make it into the sea, where a lot of it will dissolve into microplastics. All of these unpredictable factors, which are influenced heavily by climate change, make it increasingly difficult to predict the movement of plastic debris in our oceans and track down the formation of microplastics. According to researcher Natalie Weldon, the ability to predict areas of plastic input and deposition would enable the identification of at-risk species, and it would allow for efforts to reduce and remove plastic debris at targeted locations. The current uncertainty as to the effects of global warming on our oceans is the greatest challenge in predicting the future patterns of plastic aggregation in relation to global circulation. Microplastics pose an unknown danger to humans, and climate change is getting in the way of critical further research. Climate change has more effects than just those that are typically talked about, and some of its effects are compounding to create potential for much bigger issues. We need to stop using plastics so much and properly dispose of the plastics that we do use. We need to pay attention to the steady rise in global temperature and stop heating up the planet before it's too late. Right now, we've got a lot of debates about equality, but we'd better get together in this fight against climate change soon, or we're all going to end up equally extinct.